Okay, so we've got a curve, okay, which is a quadratic here, yeah, and a line, okay, and it says that they intersect at two distinct points, okay. We've got to show that this inequality here is true. Now, when we see two distinct points here, we think about two roots, don't we, okay, and they're real roots, and distinct, of course, means they're different, okay. So if you've got two distinct real roots, we often think of this discriminant thing, don't we? B squared minus 4ac is greater than 0, yeah? Because we've got the two roots and they're distinct, they're different. So, that's where we're going to get that from, yeah? That inequality here, okay? By looking at the discriminant. However, we've got two different things going on here. We've got a curve and we've got a line. How on earth are we going to get the b squared minus 4ac from this? Well, because they intersect, it says, yeah, intersect, what we can do is we can solve these simultaneously, okay? So if I call this equation 1 and equation 2, okay, we can literally say solving simultaneously. And of course, when you solve simultaneously, we're looking for results where x and y will be the same for both line and curve, okay, because they'll cross over each other. So in other words, what helps here is the y's are going to be the same, aren't they? Okay, the y's will be the same where they intersect. So if the y's are the same, I can say the top one here, the value for y at the top will equal the value for y at the bottom. So the value for y of the curve will equal the value of the line the value of the y on the line, yeah? So I can say that this will equal x plus k because the y's will be equal when they intersect. So what's good then is solving simultaneously, all right? Well, we can get everything onto one side, okay, here. So we've got 4k plus 3x plus then 7 minus x minus k equals 0. So to sort of get then to a situation where we can do b squared minus 4ac, we need to get like we've got the x squared here, but we need to get the x terms grouped together and the constants grouped together. Okay, now that can be done by sort of getting that x term there in that bracket. Now, if you can't quite see how to do that, right, what you could do is just expand that bracket to begin with, right? So you could expand that bracket. So you've got 4kx when you times there, and then you've got 3x there when you multiply out, plus 7 minus x minus k equals 0. If you then put the 3x and that minus x together, that gives you 2x. Plus then 7 minus k equals 0, okay? And then you can go back to the situation where it was in a bracket. So in this case then, because x is in both terms, you put the x at the end of the bracket like they were here, but this time it won't be 4k plus 3 representing that there, it'll be 4k plus 2. Okay, now you might have seen that straight away. You might see like, oh, you've got the 3x there, take away x, so you could just go straight for that line, absolutely. Okay, and then you've got plus 7 then minus k equals 0. So now we've got a nice quadratic where we can say a is equal to 1, b is equal to 4k plus 2, c is equal to 7 minus k. Okay, then it says, given that L and C intersect at two distinct points, show this. So we can say given two distinct points of intersection, we can say b squared minus 4ac is greater than 0. So chuck it in. Okay, and then we just got to expand this and we should then get the inequality that they want. Okay, so multiply out that bracket, so you get 16k squared. When you do the outers, then the inners, that comes to 16k. The last then is 4. Multiply out that bracket, so you get minus 28 plus 4k greater than 0. Simplify it, so you get 16k squared plus 20k. 4 minus 28 is minus 24, greater than 0. And then you get what they want by realizing 4 is a common factor here, so you can divide by 4. So you get 4k squared plus 5k minus 6 is greater than 0, which is exactly what I wanted in part A.